Hi, in this tutorial I will talk about an extension to the dynamic wall creation tutorial. I already did a grid snapping for walls half a year ago, and now I will answer this question. Please make another part where the walls connect. If you haven't seen the first part yet, which is for example right here, and the second part which I have opened here, you should do so. I will link these in the description. So let's see what we've got so far. We can create walls, and let me just try to create a room, and you see the problem already. The walls don't connect properly, so I have these gaps, and I would like to get rid of them. So what I did now is, after we create the first wall, we can activate our pole snapping tool, and now it will detect the closest endpoint of whichever wall. So I can be here with my mouse, and it will still find that endpoint here, and this allows me to create a room very, very easily without these gaps. So let's see how I did this. Okay, first I extended the setEnd method by calling another function called setEndPoles. This is here. So here I basically instantiate two more wall prefabs at the starting position and end position respectively with the appropriate rotations. To those two objects I assign the tag pole. To be able to assign the tag pole, you will first have to add another tag and then go plus here and say pole. I already did this. And then I add them to a list. To be able to use lists, please use system.collections.generic. Then you can introduce the variable by list game object in angle brackets. This denotes the generic type of objects that can be added to the list. So by saying this, I can only add game objects to the list, not integer variables, for example. Okay, don't forget to instantiate the list like this in the start method. Okay, so we set endpoles. We create them, we instantiate them from the wall prefab. We set their tags to pole, and we add them to the list. Okay, now they are in that list, and by having them in the list, I can find the closest pole to the world point, which is the point that we clicked. So here we extend the setStart method to snap to the closest pole. If we have pole snapping activated, which is just another boolean, just like X and Z snapping, it is toggled here. If get key down key code P, for example, P like pole snapping, use whatever input you're using for your program, for your game. So I just toggle it, which means I set it to the opposite by using the not operator, the exclamation mark. So pole snapping equals not pole snapping inverts pole snapping. I already did a check whether we already have objects with tag pole, because if we don't, we shouldn't activate pole snapping, so I leave it at false. This prevents errors down here. Okay, so we extend the start method. If pole snapping is activated, we adjust the start position to the closest pole that we found. So in this method, we find the closest pole and return it. After having returned it, we take its position and set the starting position to it. The starting position for the new wall, of course. Okay, so what do we do in the closest pole to world point method? We first introduce a game object closest, which at the beginning is null. Later we will return it. We also introduce a distance, which will be the minimum distance that we found so far, and the current distance, which is the current distance between the current pole that we're looking at and our mouse, our weld point. So now we iterate upon all poles. This works because we have added the created endpoles to our list. And now we go for each game object P in poles, which is the list. We just retrieve the distance between the weld point that we received up here as parameter and the position of that pole. If it is smaller than our smallest distance so far, we adjust it and we adjust the closest pole to P. Then we return it, and that's basically it to achieve pole snapping. Have fun with that.